So, today we will learn about thermistor and LDR, light-dependent resistor, and how they are used to control temperature and light. First of all, thermistor. And on the electric circuits, it denoted like this, and there is maybe thing with 1 or can be 2. Not necessarily 2, but at least 1. If it's 1, can you recognize what is there? And we're talking thermistor, something related to the temperature. What this thing is?
Thermometer. Thermometer.
You have would someone have fireplace at your home? Do you have a fireplace at your home?
Yeah.
When you need to move coals around, how's the name of this? The thing.
Fire.
Hmm?
Fire.
It's called either poker or fire iron.
Yeah.
That's what it is. So thermistor, there are 2 types, but we will be focusing mostly on one. And the same idea is behind LDR. It's made from the materials called semiconductors. The property is that their resistance is not constant. With the temperature increases, we will talk more about the semiconductors when we look into the diodes and light emitting diodes later on. For now is that when they are at a lower temperature or low light, they have very little free charges. So they have high resistance. But when temperature is increasing, you will get more and more free electrons, and more light falling on them increase, becoming more and more electrons, and their resistance decreases. So for thermistor, if you sketch a graph of the resistance against temperature, most of the thermistors, they had such relation. This is inverse proportional relation. And how these can be used to control temperature. Let's say we have that at the temperature 10 degrees, that will be temperature in degrees Celsius with resistance in, let's say, kilo ohms. And at 10 degrees Celsius, we have that resistance is, let's say, 10 kilo. And at 30, or let's say at 30 degrees, the resistance is, let's say, 2 kilo ohms. So that's the property of the thermistor. When temperature increases, its resistance decreases. Now, if we have a voltage divider, so we have power source, we have normal resistor, variable resistor, and we have a thermistor. And let's say at temperature 10 degrees Celsius, resistance of the thermistor is 10 kilo ohm. And let's say variable resistor is we set at 5 kilo ohm, and we have power supply is 30 volts. What will be the voltage across the variable resistor? What will be voltage across the thermistor? Using ratios, we have voltage across resistor over voltage across thermistor will be same as the ratio of the resistances, 1 to 2. Can you divide 30 volts in the ratio 1 to 2?
Yeah.
What it will be?
10.
And so we have 10 volts here, and we have 20 volts here. Now temperature start increasing. And let's say when we have temperature 30 degrees, we have this is 2 kilowatts. This remains 5 kilowatts. Still 5 kilowatts. But ratio still has to be ratio of the voltages equals ratio of the resistances. So we'll have 5 to 2. So how the voltage will be divided? Now this one probably not the best numbers to. I will make it, instead of 2, I will make 3 to make it easier to do ratio. So if it's 3, here, so we have 5 to 3. Can you divide 30 volts in the ratio 5 to 3?
Yeah.
What is 30? 30 divide, we add 30 divided by 8. What is
15 on 4. 15 on 4.
And what is 15 on 4 equal?
3.75.
3.75. So 3.75 times 3, 9, 2.1, 11.25. So we have 11.25 here volts, and we have 28.75 volts. So what happens with how voltage is shed when temperature increases? We have less, because this will be less and less resistance, there will be less and less voltage across this, and more and more voltage across that. So, what we want when temperature increases, what you would like to turn on? Heater or air conditioner? When temperature increases? Air conditioner. So, to turn on air conditioner, where we should connect it? Across thermistor or across variable resistor?
Connect what?
We want to turn on air conditioner. When temperature increases, you want to turn on air conditioner.
So increase resistance.
So we need across the variable resistor.
Yeah.
So what we do, we connect here some switch that will be voltage out. When temperature increases, we'll have more and more voltage here until it reaches certain value, when it click and it turn on aircon automatically. If you want to, so this voltage out for aircon, where we should take voltage out if you want to turn on heater?
Thermistor.
Because then when you want to turn on heater, when temperature drops. When temperature will be dropping, we'll have more and more voltage across the thermistor and less voltage across there. That voltage out for heater. Make sense?
Yeah.
So, and we can set temperature, at what temperature we want to increase, at what temperature we want to turn on air conditioner or heater. By changing this one. If we change this resistance, we can choose at what, let's say we don't want to 30 degrees is too hot, we want to turn on air conditioner, let's say at 25. And let's say that at 25 we have resistance of the thermistor 5 kilo at 25 degrees. We want to turn on air conditioner at 25 degrees. Question is, and air conditioner we take voltage out there, and we have and we need let's say 20 volts to turn on air conditioner, we need 20 volts. Question is, what we should set the resistance of the variable resistor to turn on air conditioner at 25 degrees?
A 2-to-1 ratio of resistance.
Then we have 2. This is, what this is at 25 degrees, what resistance is?
5.
5 kilo. That means we want voltages 20 volts to 10 volts. And that has to be R to 5 kilo ohms. So what we should set the variable resistor? R equals 10. And that's what we're doing when we set the temperature of the air conditioner system. At what temperature it turns on, we're changing variable resistor. We're changing variable resistor. And we can set whatever temperature we want, because it works by the distribution between the thermistor and variable resistor. Make sense? Does it make sense? Now, the same idea is behind automatic, when lights turn on automatically, when it becomes too dark. And then we're using, instead of the thermistor, we're using LDR, light dependent resistor, which is on the diagram, resistor, and showing like light falling on it.
What page is this?
That's-
It's not really a page.
Yeah, I will tell you which pages it is. I will tell you. Let's first have a look here. And again, we will have, the only difference is that resistance, and here we have light intensity, which is measured in lux. And again, we will have the same voltage divider. And we have variable resistor, we have LDR. So we have LDR, sorry, we have voltage, we have variable resistor, and we have LDR. Now, when we want to turn lights on, when it becomes dark or it becomes very bright? Dark. So what happens with the resistance of the LDR when it becomes dark? Less and less and less light.
Yeah.
What happens with the resistance of the
Higher
LDR?
resistance.
Becomes higher. So where we should connect that switch that will turn on lights?
On the LDR.
On the LDR. So that is to switch light. To switch light. And let's say to switch light we need 6 volts. We need 6 volts to turn on lights. And we want to turn on lights when we have 25 lux. When the light intensity is 25 lux. Lux is a unit of light intensity. What should be the value of the variable resistor?
5 times the LDR.
We have voltage is 6. What voltage across the variable? The total 30. 24 volts. So ratio of the voltage is 24 to 6, 24 volts to 6 volts has to be ratio of unknown resistance to the resistance of the LDR, 5. R to 5. From here, R equals what?
How do you get this 5? 20.
Why this is 5?
Yeah.
When we're saying 25 lux,
Oh, for example. Okay.
that is from the graph. You need a graph with the properties of the
Alright.
thermistor of LDR. So then R will be equal 20 kiloohms. Make sense how the thermistor and LDR can be used in the automatic control system based on the simple voltage divider. So that's all new material for today. Like, subscribe and donate to help fight against Russian fascists, support Ukraine and Israel.
Good.